Today, we're jumping right into the middle of a war. It's a battle being waged every single time you log into anything, a constant fight between a password you can actually remember and one that a computer can't possibly guess. We're going to break down the science, the psychology, and the strategy behind this whole mess. So let's start with a feeling I know you've had. That moment of pure, hair-pulling frustration. You're trying to log into some old account, you've tried every password you can think of, and boom, you're locked out. But here's the thing, that's not your fault. It's not a personal failing. It's a fundamental design problem baked into our digital lives. And this frustration comes from what we're calling the password paradox. It's this basic conflict, right? It's a total clash between how our brains are wired, we're all about patterns and simple things, and the just relentless brute force power of modern computers. And this slide just lays it out perfectly. I mean, look at this. On the left, you've got dog, cat, 1, 2, 3. It's simple, it's memorable, our brains can handle that no problem. But for a computer, that's not a lock. That's a welcome mat. Then on the right, you have, well, cryptographic chaos. It's a complete nightmare for us to remember, but it's a fortress against a machine trying to guess its way in. That right there is the paradox in action. You know, researchers actually have formal ways of modeling this. On one hand, you've got the usability model. This is all about us, all about cognitive science. It basically measures how many times you have to mentally rehearse a password before it sticks in your brain. But then there's the security model, and that's all about the bad guys. It thinks about every trick in the book, from online guessing to what happens if hackers steal a whole database of passwords. And this leads to something that sounds totally wrong at first. We are constantly told, do not reuse passwords. And yeah, for security, that's absolutely right. But from a purely cognitive point of view, reusing a password actually helps us. Every time we type it in, we're practicing it. We're increasing its natural rehearsal rate. It just perfectly highlights this deep, deep conflict between what our brains crave and what good security actually demands. So if that's how our brains are wired, what if we just stopped fighting them? What if we could design systems that work with our psychology instead of against it? Well, it turns out we can, and one really clever way to do it is by focusing on sharing cues instead of secrets. So one of the most promising ideas here is something called the shared cues scheme. Now, the big idea isn't to share your actual password. That's a terrible idea. Instead, you share little hints or cues that are all derived from one single core secret that you know really well. This way, your brain gets the repetition it needs to remember things, but all your accounts stay secure and separate. So how does this magic actually work? Well, it's pretty slick. You start with one main secret, something easy for you to remember. Then, the system uses some really smart math to basically slice up that secret into unique but related cues for all your different accounts. And the result is amazing. When you log into your email, you're subconsciously practicing the hint for your bank login. The whole thing just feels easier, more natural. Okay, but what about the passwords we already have? Let's be honest, not all of them are going to be masterpieces of complexity. We all have a few weak ones floating around. And that's where this powerful cryptographic shield comes into play, working behind the scenes to protect us, well, from ourselves. The first layer of this shield is something called a Pock. That stands for Password Authenticated Key Exchange. Basically, its whole job is to let you and a server establish a super secure connection using just your password, but without ever sending that password out in the open where someone could grab it. And crucially, it's built to stop those dictionary attacks, where a hacker just tries every word in the book. And this packet tech has gotten a whole lot smarter over the years. See, the early versions had a tiny weakness. If a hacker broke into a server and stole its password data, they could do a ton of the hard math ahead of time to make their guessing attacks way, way faster. But the next generation, these strong opaques, they close that loophole completely. They use advanced tools to make sure that even if the server is totally compromised, your password is still safe from those kinds of speed-up attacks. And all of this really shows that modern security isn't about finding one single silver bullet. No, it's about layering. It's about using multiple cryptographic tools to build a fortress. A system so strong it can take even the weakest password and make it incredibly tough to crack. So let's just imagine a security admin's absolute worst nightmare. Millions of people all across the internet are all using the exact same ridiculously simple password, password 123. If an attacker figures this out, they've basically got the keys to the kingdom. Well, the solution is just beautiful, and it's called salting. Before a system stores your password, it adds a unique random string of characters, the salt. Think of it like a secret ingredient. So even if you and a million other people use password 123, every single version stored in that database looks completely different. An attacker can't just break one to break them all anymore.
And salting is just the beginning. This cryptographic toolbox is packed with other cool stuff. You've got key derivation functions, or KDFs, which take your simple little password and mathematically stretch it into a super long, super strong cryptographic key. Then you've got slow hashing. This is genius. It intentionally makes checking each password guess slow. For you, it's a millisecond you'll never notice. But for a hacker trying billions of guesses, it makes their attack painfully slow and expensive. And finally, things like MI security make sure that cracking 1,000 accounts is 1,000 times harder than cracking one. No bulk discounts for hackers.
So, after all this talk of cryptography and cognitive science, what's the big takeaway? Why does any of this actually matter to you when you're just trying to log into your email? It means that securing your digital life isn't just on you anymore. It's not about you just picking a better password. Real security today is this sophisticated, multi-layered strategy. It's a combination of understanding human psychology, building smart systems like shared queues, using powerful protocols like Pock, and leaning on those fundamental crypto tools like salting and slow hashing. Every single layer supports the others. And really, that's the bottom line. Good security is a partnership. It's a team effort between what you can reasonably be expected to remember and these invisible, incredibly powerful systems that are working 24/7 in the background to back you up. So the pressure isn't entirely on you to be perfect. The system is designed to help. And all of this leaves us with one last kind of fascinating thought. We started this with the simple frustration of just forgetting a password, right? But as we see all this incredible innovation, smarter crypto, more human-friendly design, you have to wonder, are we watching the beginning of the end for the password itself? I mean, what does logging in even look like in a future where our systems are smart enough to protect us no matter what we remember?